All right, I should now be recording. So this is a lesson on limits involving infinity. What I want to do in this first video is just start with a basic example and talk about infinite limits when you have a vertical asymptote and a limit at infinity when you have a horizontal asymptote. In the OpenStax textbook, this is going to be section 4.6. So let's start with the graph I have on the screen. This is the graph of the equation y equals 1 over x. So let's begin looking at a limit. We're going to look at the limit as x approaches 0, just from the right of this function, 1 over x. So I'm going to start by exploring this numerically, and we can talk about it graphically over here as well. Let's pick a value close to 0. Like 0.1, 1/10, right? If we put 1/10 into this function, 1 over x, then we get 1 divided by 1/10. This is equal to 10, right? If we pick a number even closer to 0, 1/100th, then of course 1 divided by 1/100th equals 100. 1 over 1/1000 equals 1000. So we see this behavior going on. It's getting bigger and bigger. As we get closer to 0, the resulting reciprocal is going to get closer to infinity. So over here, we see that behavior in the graph as well. Here it is going up, shooting up forever, getting closer to infinity as x gets closer to 0, at least from the right-hand side. So from the left-hand side, you can see it's getting close to negative infinity. Now, technically, it is true to say that in this case, the limit does exist. So we can abbreviate that dne. However, it just provides more information, more useful to say that the limit is equal to infinity, positive infinity in particular. Remember that infinity is not a number. However, in the context of limits, we do use it like a number in some ways. So, there's our first. Now, the next example, we're going to use the same function, but this time let's look what happens as x approaches infinity. This idea of x approaching infinity is something I probably haven't talked about much yet, but it's exactly what you'd expect. What you want to do is look at larger and larger and larger x value. Now, this is positive infinity in particular, so we want to do numbers like 1,000, 10,000, million, so on, and you can get as big as you want. And as the numbers get bigger and bigger and bigger, we want to see what's happening to the y coordinates, the outputs of the function. And if there's a trend towards something, that's equal to the limit. So in this case, if we use 1 over x, we can examine this numerically as well. And I'm going to mimic what we have up above here. If I use x equals 10, we get 1/10. If I use x equals 100, we get 1/100th, 0.01. If I use x equals 1,000, we get 0.001, and so on. So it's pretty clear, as x gets larger and larger, the reciprocal is going to get smaller and smaller and smaller, approaching 0. In fact, approaching 0 from the right-hand side, from above, which is what we see going on over here. As we go out, we're getting closer and closer to the x-axis. Okay, so this is just 2 examples. Now, this is a function that has both a vertical asymptote and a horizontal asymptote. We have our vertical asymptote here. Here, you know what? Let me switch colors. Use some sort of orange color. Maybe we have a vertical asymptote here at x equals 0. Now, a vertical asymptote is essentially defined as an x value at which the function's limit from either the left side or the right side is equal to positive or negative infinity. As long as you have the limit from one side or the other equal to infinity or negative infinity, that's going to be a vertical asymptote. The horizontal asymptote, right here at y equals 0, a horizontal asymptote is defined by simply having the limit either at negative, as x approaches negative infinity, or as x approaches positive infinity, equal to some constant. So in this case, it's 0, but you can have functions with a horizontal asymptote at 5 if the limit as x approaches infinity or negative infinity is equal to 5. In this case, it's both sides. You can see in this example, the right-hand side and the left-hand side, the functions approaching 0 on both sides, but that's not necessary for a horizontal asymptote. You can have a horizontal asymptote where it's just one side or the other. You can also have functions, and let me just draw an example picture. You can have a function that maybe goes like this, that has, say, y equals one number a, and then another horizontal line over here, y equals another number b. And this is an example of a function that can have two horizontal asymptotes. So it's still a function, right? It still passes the vertical line test. It does have two horizontal asymptotes, right? And that's because the limit of this function as x approaches negative infinity, and I'll just call it f of x, I guess. This is a. And the limit of this function as x approaches positive infinity is equal to b. So it's possible to have two horizontal asymptotes. All right, one of the things you may have heard about asymptotes is that a graph cannot cross over its own asymptote. That's true, more or less, of vertical asymptotes. I would say that's true of vertical asymptotes. You can't cross over it. It is okay to touch a vertical asymptote from one side. But it's definitely not true of horizontal asymptotes. So if you've heard someone say a graph can't cross over its asymptote, that's nonsense. Let me show you why. Here's an example. We're going to do a new function and call it cosine, call it g. It's going to be cosine of x divided by x. Let me get a picture of this. You can probably imagine what this looks like. I'm going to pull over Desmos here. Here's cosine of x divided by x. Okay. It has a horizontal asymptote here at 0. But then, like a cosine usually does, it has some sort of like wave-like tendencies, right? It has this sort of wave-like behavior. Let's adjust our bounds a little bit. I'm going to adjust the y-axis, so it just goes from like -2 to 2. So I stretched out the y-axis, but kept the x-axis so that we can see out a long way. So I'm kind of, this picture is kind of amplifying the amplitude, increasing the amplitude of the wave a bit, just to give us a better idea of what it looks like. And as we can see, it's oscillating back and forth, right? But those oscillations are getting smaller and smaller and smaller and smaller, just like the 1/x graph would be doing. So if you kind of look at the peaks here, these peaks are all kind of off, like they're following the same trend that 1/x graph would follow. And so despite the fact that it's oscillating back and forth, it does have a limit at infinity equal to 0 as we go out and out and out and out. We're going to get closer and closer and closer and closer and closer to 0 because the oscillations are getting smaller and smaller and smaller. But we still have an infinite number. We actually always have an infinite number of these x intersects. Okay, so this is an example. I'll go back here. This is an example where as we go towards infinity, like written like this, this is equal to 0, but the graph intersects its own horizontal asymptote at 0 infinitely many times. Okay, so there's just another example of a limit at infinity and a horizontal asymptote.